Today we will discuss about ILS site cooling system, which is EFC, Emergency Free Cooling Unit. This machine is manufactured by Schneider Electric under the brand name of Uniflare. This machine is having a rating of 0.8 TR and 1.3 TR. These are mostly installed at ILA site inside the shelter for the cooling of electronics equipment which is mounted inside the shelter room. In this video presentation, we will discuss on overview of ILA, hardware mounted inside the shelter like passive and active equipments. Also, we'll see the airflow for routers and for the air conditioners. We'll discuss on the basic problems like air leakage from the shelter and other places, high condensate from the EFC machine, high temperature alarms, wrong set points, continuous compressor runovers and higher electric consumption. Also we'll discuss on the resolution method that how to resolve the shelter leakages from the EFC machines and how to set the right temperature settings after doing all corrective actions. Also we'll see about the condenser coil and its cleaning. We'll also discuss on the controller set points and other parameters which are visible in the controller display. We'll also see the operation logic of the damper in the free cooling and in emergency free cooling mode. Also we'll see the filter cleaning inside the active electronics equipment as well as in the EFC machine. We'll also see the positioning of active racks and what best is doable at field level. And at last, we'll discuss on the key 8 tasks what we have identified to improve the performance of the ILA, and we are daily circulating the dashboard. Here we can see the two photographs in this slide. The right hand side photograph which is showing the rack which is installed on right hand side wall of the shelter. In this rack, if you see from top, this is a DC-DB. After this is a vacant space. This is a Sunsi make fiber termination unit. Just before this unit, this equipment is installed, which is called Alcatel Lucent electronic equipments. You can read the model number 1830PSS-32, and below this equipment again there is a fiber termination unit is installed. So in this rack, we'll see that this is the main equipment which requires air conditioning. We need to understand that from where the cool air is entering in this equipment and from where this hot air is coming out, so that we can determine what is the correct positioning of this equipment and whether any alteration is required or not. In this slide you can see the two photographs. Left hand side photograph shows the supply air direction. You see the paper here, this paper is placed here, and you see that paper is getting inside. It is trying to go inside this gap. So direction of this air is inward, like supply air is coming from EFC unit and it is going inside this gap, and from there it will travel to top and it will cool this equipments will get cool, and this supply air will become hot air and it will discharge from the top. Now just look at the right hand side photographs, which is a discharge air. So here we can see that this is a top portion of this air will come from this way, and then finally it will cool this all these units. It will become hot, and from this hot from this place it will go on top side. But you see this, the Sienna Sun Sea equipment is placed here, and because of this Discharge air doesn't have a proper path to move in upward direction. And finally, this air is coming out from this gap and is again mixing with the this and creating a short cycle. So this is not the effective way of cooling. Because of this short cycle, the equipment cooling is not happening properly. In previous slide, we have seen that how the short cycling is happening in the Alcatel Lucent equipment. If you see the photographs, you see that this is the worst kind of installation. Why? Because hot air which ideally has to travel up is not traveling on upward side. Instead, it is coming out from this gap and it is again mixing with the cold air, because this area is not sufficient and it is not allowing this air to travel on the top side, because this Sunsi equipment which is mentioned, which is placed here, it is wrongly installed and it is blocking this air. If you look at the this photograph, we have removed the this screws and we have placed this equipment on 2U above, and we see that this is the gap now available. We see that the fins of the exhaust fan which is mounted on this place, and now this air is having some more volume and it is getting proper area to cool down, and it is now can go on upper side also, because there is a space has been increased. If you look at on the this last photograph, what we are saying, this is the best installation, because now further this unit fiber termination unit has been repositioned on the maximum on the top side. So now this is the vacant space is available, and from that this air is ideally going on top side and it is overall improving the cooling efficiency. Before this air was actually coming out from this fan, and instead of going upside it was coming like this. It was also going on this equipment also. So this is another rack, and this right hand side is having a suction. So this rack was sucking this hot air and creating a problem for this router, that we will see in the upcoming slides. In this slide, we will show you a small video clip in which you can see that improvement in the hot air discharge from the Alcatel Lucent equipment. Fiber termination unit is moved upward direction by taking a help of fiber team, and finally the hot air discharge airflow is drastically improved and effective cooling is taking place. All teams are requested that whenever they visit the site, they have to see this arrangement, and if this gap is not sufficient, they have to immediately call the relevant team, and they have to ensure that proper cooling space is maintained. In this slide, we'll see the installation and airflow of Cisco router. In the rack we can see that there is a four routers are installed in the rack. This rack is installed on the very next to the Alcatel Lucent rack. We can see that this is a gap between these two racks. Now normally the right hand side of this router unit is having a supply air section, and from left hand side it is discharging the hot air. If you see the zoom view of this, you see that this is the place from where the hot air supply air is going inside, and there is a filter unit also. Once it is going inside, it is going like this, and it is cooling this equipment all the way. It is getting hot and coming out from this place and going back to the EFC unit. In this slide, we will see the video clip of filter removal and cleaning of Alcatel Lucent equipment. This removal of filter is being done by the trained field staff of electronics teams. Utility team has to ensure that proper air circulation is happening. In case of any issue, they have to call the right person to remove this filter and to clean. Cleaning of filter has to be done outside the shelter so that dust does not get circulated inside the shelter. In this slide, we will see the thermal imaging of supply and return air. This is the bottom portion of the EFC unit, which is a supply grill. From here, the air is coming out, and the temperature of this air is 23.8 degrees centigrade. We can see this air is going towards the electronic rack, and it is cooling the rack module and coming back and going again to the return air grill, which we can see in this video. Here we are focusing on the bottom part, and slowly we will move our thermal imaging sensor towards the return air grill. As we move our sensor towards the upper side, we can see that the temperature on the left corner is getting increased, and now it is showing a 30, almost 35 to degrees centigrade. That means there is a difference of around 8 to 9 degree centigrade. In this slide, we will see the sunlight test of the shelter. To conduct the sunlight test, person has to go inside the shelter, and he has to close the door firmly, and he has to lock it from inside. After that, he has to switch off the light inside the shelter and then look for any penetration of sunlight from the edges of the door. In this picture we can see that this is the place from where we can see that sunlight is visible. It means this fresh air is getting leaked from this place. If you see the carefully, the black color gasket is perfectly fine, but at this place this gasket has been damaged, and for that it is not getting sealed properly. If you look at this bottom and all this across all this edge, the gasket is firmly sitting with the door frame, but particularly in this place it is not perfectly sitting, and due to that there is a gap is created and air is getting leaked. We are seeing all across the door, and we see that on top side there is no leakage, but on the left hand side also we can see that this is a place where gap is there. Again we are closing the door, and again we are re-verifying, and we are seeing that at the same place we are seeing the gap, and we need to correct the gasket. In this two picture we can see on the left hand side that door gasket is damaged and it is not sitting properly with the door frame, and because of that there is a gap. On the right hand side picture we are seeing the cable entries which is entering into the shelter from the bottom side, which is also sealed. During every visit of technician, it has to ensure that any leakage from the rock stack also to be sealed with the silicone sealant, so that fresh air leakage can be arrested. In the next slide we will show you what is a remedial action can be taken which is durable and economical to arrest the gasket leakage. To arrest the leakage of gasket, there is no need to replace the full gasket altogether. If leakage is minor, and that also at the few places only, then it is better to buy a foam type gasket. If you see in this picture, this kind of foam type gasket is available in any small hardware shop. The properties of this gasket is that it is very compressible. You can easily press it, so it can sit in any small places very easily. One side it has been stick with the adhesive, so whenever you find the leakage, let's say in the right hand side of the picture you see that this was the place where the door gasket was not sitting properly and the gap was created. To fill this gap we have taken this foam type gasket, and we have removed the yellow cover from that, and we stick on the door frame wherever the gap was observed, and immediately you can just press it properly and this will sit there permanently. After that if you will close the door, that door gasket and this gasket will sit on face to face each other, and whatever the gap is there it will be removed easily. This solution is very handy, speedy and economical. So kindly look for the foam type gasket from the nearby hardware shop and fix it over wherever you see the leakage, especially on the door frame. In this video clip, we will demonstrate you that first of all there is a leakage on the door frame because of the small portion of the gasket is damaged. After that we will put the foam type of gasket at that particular area, and we will reclose the door, and we will see that now there is no gap and there is no leakage and there is no sunlight coming inside the shelter. After that again we will remove that foam type of gasket just to show you that now again gap is created. So foam type gasket is very workable and it is a very important and easy solution to arrest such kind of leakages. In this video clip, we will see there is a opening is there in the backside of the EFC, and this opening is also allowing us the fresh air leakage, and that is why it is very important that any opening is there to be sealed properly. Here also we are putting a foam type of gasket after cleaning the surface area so that it can stick properly. This opening is on the back side of the EFC unit. Once you remove the back cover, you will see the hole which are not plugged properly. Ideally, it has to be sealed with the rubber grommet or some silicone, or you can use the foam type of gasket also. Please look at this video for more details. In this slide, we will discuss about controller set parameters. This controller is located on the back side of the EFC machine. So to access this interface, person has to open the back door of the EFC, and then they can access this interface. If you look at in the display, it is mentioned OD, which is a 27.1 degree centigrade. OD is nothing but the ambient air temperature or outside air temperature. If you look at the next value, which is ID, the value of the ID you can see it is 29.3 degrees centigrade. ID is nothing but the inside room temperature or return air temperature. The air which is coming from a rack to the discharge to the suction grill of the EFC is measuring this temperature. The sensor is placed at the entry point of the air which is coming from the rack towards EFC unit. At down you can just see that delivery air temperature is that the supply air temperature, that means the grill temperature from where we are getting the fresh air from the EFC machine, which we can see it is a 25.2 degree centigrade. If you look at the this picture, you will see that mode is normal. That means there are three different mode for this EFC machine, where the EFC compressor is running on the AC power. That means it is running on the normal mode. When outside air temperature or ambient air temperature is 5 degree lesser than the set point temperature of the EFC, that time the damper will open and compressor will switch off, because the ambient air temperature is very less, and that is why it will switch off the air compressor and it will utilize the ambient air temperature air to cool down the shelter, and this mode will be calling as a free cooling mode. During the free cooling mode, this LED will glow. In case of AC power is failed and DG is not started because of any reason, at that point of time shelter temperature will increase, and to maintain the temperature this blower will run on the DC power, and it will be knowing as an emergency free cooling mode. So these are the different mode of the controller. If you look at here, the bottom line, you see the compressor voltage and CC is the compressor current. Here it is shown is a 0 ampere, that means compressor is in off condition. At the this picture you will see the damper position. Damper is closed, that means free cooling mode is not activated. In this picture, you will see the set point temperature. Here the set point temperature we have kept now is 32 degree centigrade. This temperature earlier it was 29 degree centigrade. Now we have changed from 29 to 32 degree centigrade, which is the design air temperature. And this is we are seeing that 2 degree is a hysteresis. Meaning of this is, if you set a 29 degree centigrade as a set point, that means the EFC machine will switch on the compressor when your return air temperature will be 29 plus 2 degree. That means over and above 31 degree centigrade temperature will reach inside the shelter. At that point of time only your EFC machine will switch on. Now we have changed our set point from 32 degree centigrade, and that is why, and 2 degree is a hysteresis, so 32 plus 2 is 34. So now EFC machine will switch on or after 34 degree centigrade. So that is how we are delaying the compressor on time, and we are also reducing unwanted compressor hours, and we are saving the energy. Here we have shown the return air temperature sensor, which is mounted very close to the return air temperature grill in the EFC machine. Return air temperature grill is on the top side, and the supply air grill is on the bottom side in the shelter. This sensor has to be carefully placed at this location only, because it will decide your compressor whether to switch on or switch off. In previous slide we understood that how the damper is operating and in which condition. Damper operates only in free cooling mode, and free cooling mode gets activated when your set point temperature and your ambient air temperature is having a difference of 5 degree or more. So let's say if your current set point of return air temperature is 27 degree, that means your damper will only operate if your ambient air temperature is less than 22 degree centigrade. If you increase your set point from 27 or 28 to 32 degree centigrade, in that condition 32 minus 5 is 27. So when your ambient air temperature is less than 27 degrees centigrade, at that point of time only your damper will open, and it will allow your fresh air inside the shelter. And the other case is that when your grid power is failed and your DG power is also failed, in that condition, to maintain your room temperature, damper will open in a emergency free cooling mode. Damper is having a one stepper motor, or it is called a damper motor, which is giving a 180-degree movement of the damper on the y axis. We have to ensure that damper has to be closed on face to face with no gap. If there is any gap found, kindly use a foam type gasket and fill the gap so your fresh air leakage can be arrested. Your damper should operate only as per desired condition. If your operation logic is reverse, or by mistake if there is any issue, then your damper will open during your compressor running, and it will totally disturb your cooling system, and it will waste your electricity also. Hence you are requested to take care of your damper operation and ensure the healthiness of damper motor, damper door, damper gasket in every PM schedule. Now the damper is getting close. In this picture we can see that the compressor coil. The compressor coil is is blocked with the dust particles at many places, and because of this choking the cooling efficiency of compressor is drastically reduced. It is recommended to clean the compressor coil with a soft and smooth brushes and to remove this choking dust particle to have a better cooling efficiency. In this picture we can see the air filter, which is a very important part of this EFC unit. This air filter is located on the back side of the EFC machine. Person has to use the aluminum ladder and he has to safely open the back cover and to remove this air filter from the back side. After removing that, this filter has to be cleaned with water and it has to dry for some time. Once it is dried properly, this filter has to be fit back inside the EFC machine. Filter will improve your cooling efficiency and it will help to maintain the shelter temperature as per the requirement. In every PM schedule of OEM and by the SP technician, the filter cleaning is mandatory in all kind of preventive maintenance. In this video, we will see the condensate measurement. This measurement is very important and it is showing the healthiness of overall cooling system of the shelter. If your condensate, it means your water rejection from EFC unit is more. That means that you have a fresh air leakage inside the shelter and the maximum capacity of the EFC machine is being utilized in generating the condensate. So we have to ensure that there should be zero leakage inside the shelter, and once the leakage is not there, definitely your condensate rejection will be reduced. Once you are 100% assured that leakage part in the shelter, in the EFC, in the damper, everywhere it is plugged out. Thereafter only you have to check the condensate, and once the condensate reduction is ensured, then you can increase your return air set temperature from 28 or 29 to 32 degree centigrade. Hi, this is a last slides for our video presentation. We have identified key tasks which has to be complied on ground by the field team. Task number 1 is door gasket replacement and its rectification. Whenever we found minor leakage from the door gasket, there is a no requirement to replace full gasket. You can buy the foam gasket from any local hardware shop and you can fix your leakages. Even leakages from damper and EFC also can be arrested by using silicone or by foam-based gasket. Task number 4 is damper logic and its operation. As we discussed earlier in detail that damper operates only in two conditions. Condition 1 is the difference between your set point return air temperature and ambient air temperature is more than 5 degrees centigrade. Or condition 2 is the site is running on battery and to ensure minimum cooling, damper will open and it run in emergency cooling mode. This operation logic has to be checked by doing simulation at site. Task number 5 is shelter door tightening at hinges. Task 6 is a very important task and which is to measure the condensate, which is nothing but a water rejection from the EFC machine. Before doing any rectification for leakages, you have to measure the condensate. After doing all rectification for shelter leakages, again the condensate has to be measured and you have to see the difference. If difference is there, it means that whatever the leakages has been arrested has turned into the effective and it has increased the overall efficiency of the compressor. Once you ensure the compliance of task 1, 2, 3, 4, 5, 6, then only you can increase the set point from current temperature to 32 degree design temperature. Before doing this temperature increase activity, you have to ensure the proper filter cleaning of active and passive component, condenser coil cleaning as well. Task number 1 to 6 is also applicable for NLD AG1 as well as AG2 sites. Only set point has to be followed as per the design specification. We request all infra lead and infra engineers to religiously follow the guidelines and ensure the compliance of this task, which will finally give us a good energy saving. Kindly have a training session with your colleagues and with your reportees also and cascade down the line. Thank you very much.